All right, next I'd like to invite up on stage Ramdev C M. He's a software engineer at Unacademy. His interests include software reliability engineering and DevOps. He believes in think, create, engineer, repeat. He's also a Red Hat certified system admin. Here to talk about maximizing efficiency and savings. Can we have a loud round of applause for Ramdev, please?
Hi everyone, it looks good to see you all from here. And myself, like Ramdev, I work at an academy. I started my career with like SRE, then moved to backend dev. Now I'm working as a data engineer at an academy. And this is just a fancy title. I got it from ChatGPT, nothing. So I'll be mostly covering or I'll be deep diving to Redshift. So I just want to know how many of you have used Redshift in your org or in your projects. Or first, how many of you are data engineers? Great. Okay. And also one more question. How many of you have used schedulers like Airflow? There are a lot of schedulers. You can deploy your own schedulers. Airflow is one scheduler. You can use Django schedulers. How many? Cool. Okay. So yeah, just an architecture of Redshift. So we will call Redshift or Redshift clusters from our applications. Let's say our analytics applications are using Redshift for doing certain Redshift operations. So we'll be calling that using JDBC or ODBC. I hope you are aware of what JDBC and ODBC is. J is for Java and O is for open. And database connectivity, that's it. And every Redshift cluster will have a leader node plus compute nodes. You can either have one nodes or multiple nodes. So in leader node, what it basically does, I'll cover it in the next slide, but just think this is the architecture of Redshift. It has like, again, deep dived models or architectures within this, but just a basic thing. This is how it is. And yeah, key components. So I'll just brief what things are in simplified manner. So basically clusters. Clusters are like, if you spin up a cluster or if you spin up a Redshift cluster in Redshift, in Amazon AWS, we will get a cluster. So it will have basically one node, and you can create multiple nodes within these clusters. That's why we call it a cluster. So every cluster will have a leader node and multiple compute nodes or like multiple compute nodes. And what leader node does, it basically analytics team will fire the query to leader node or to the cluster. This leader node will process the query and it will do certain compilations and operations, and it will send it to the compute node. So what compute node does, or what compute node means, it will just do compute operations. Like you want to do some join operations or you want to do some things, the data basically stores in the compute node. So even like if we slice down the compute node, we can find node slices. So Redshift is like a big machine, and if you want to do hardcore operations, you need to break down that machine into simpler parts. That's how we do in programming language, right? We can't write an entire company's code in one. We can, but that's not an optimal way. We do modular approach or functional approach. So in the same way, Redshift also has that architectural classification where the compute nodes are divided into node slices, and data or whatever like operations, we can do it in these slices. So yeah, then next I want to cover, that's all about like Redshift and what it does. Now I want to cover like how we can save the cost. Anyone have an idea like how much your company incur for Redshift? Cost for Redshift? No idea? Okay, cool. So I'll basically give an overview. Some companies can, like, I'm talking about monthly price. Some companies can get charged like $100K, like $1 lakh, $1,000, $10,000, etc. It depends on the load, it depends on the company's growth and scale and other things. So we all know what reserved instance is, right? Anyone, like, I think everyone knows reserved instance. Can you please raise a hand who know reserved instance? Cool. What reserved instance means is we are purchasing and some sort of like some number of instance for a dedicated time. And so whenever we purchase a reserved instance, there are like chances or possibilities where we will need to hold that for a long time. If we want to switch some of the instance classes that can't be possible, or we'll need to go through some like legal formatting, or we'll need to sell it in the marketplace or something. So when you plan to buy a reserved instance, be very mindful. It's a commitment. So what we would suggest, or like what we have done, was to analyze our cluster's load, let it run in an on-demand for a month. If you plan to pay like $100K for a month for reserved instance, and if it's charging like $150K per month for on-demand instances, if you can optimize that 150K month to like 50K, then you don't have to pay the rest 50K for the remaining years. So that's how. So first run your Redshift instances in on-demand, and like explore or do maximum optimizations that you can do before purchasing RIs. So once those things are optimized, then you can definitely go for RI. Then the other things, I've already covered the optimizations. Then commitment cost, that's what I mentioned, like think twice, commit once. So if we purchase, like we can't go back, or it's very challenging to go back to like the other instance types. And this is a graph where I can like show. We had like we used to pay like $108K per month, and where we are now, it's like 26K per month. Anyone surprised? I don't know if this makes sense, but yeah, from 16 nodes to just 3 nodes, and we are trying to make it to 2 nodes. So that's how we did our engineering. Like we did our optimizations, we did lot of like engineering excellence to bring this exponential like decrease in cost. So how? The first thing was RI, I already discussed. Then the next thing, AWS has an advisor for Redshift where you can see all the recommendations for your cluster, for your tables, etc. And you can just copy paste, run this query in your cluster, and you can optimize your clusters, or you can optimize your tables. You can find it in Redshift, like in Redshift page. Every cluster will have its recommendations or advisors. You can find it there if you're using it. So yeah, AWS itself gives this opportunity. So why wasting it? Just run this command. You won't like lose any kind of data or something. They will just restructure your data, and you can see the performance like in 2 or 3 days. And next one is WLM. Anyone heard about WLM? Data engineers, WLM. So WLM is just like workload management. And how it can help Redshift cluster optimization. So basically we have queries, like hundreds and thousand number of queries will be fired to a Redshift cluster. So it will take all the load, it will run how it used to run. So just doing some sort of optimizations here and there, we can again optimize our cluster utilizations, compute utilizations. So what WLM is, we have 2 types of WLM, automatic WLM and manual WLM, that I'll cover in the next slide. But this is just how WLM can help you in optimizing your queries. Yeah, I told we have 2 types of WLM, one is auto and one is manual. So in auto, we can set our query priorities. Like if you have ETL queries, how many of you have heard about the ETL? ETL? Cool. Okay. So if you have ETL queries, you have dashboard queries, you have report queries. So you can categorize those queries based on query groups, and you can like set the priority. I want to run my ETL at the end because I want to process more data. So in that case, you can set the priority like of ETLs to normal or low. And if you want your dashboards to populate more faster, if your dashboard queries need to run more faster, you can like you can use the priority as high, so that those queries will be like ran faster, preferred faster from the queue. So that's why we use auto WLM. And in manual WLM, like we can say our query need to use this much memory, this much CPU, or those kind of things can be set in manual WLM. So if you can deep dive into your Redshift cluster, if you can deep dive into the operations that it performs, so those things, if you can do that, then you can definitely implement manual WLM, because auto WLM will be done by Redshift, like from AWS side. You don't have to worry about that. You just need to set the priorities. That's it. But in manual WLM, you will need to do more engineering into like the queries, into the load that the cluster takes, etc. And this can like basically reduce the cost because it will reduce the utilization. If utilization reduces, you can reduce the number of nodes. Then you can reduce the cost. Then the next one is data hygiene. How many of you have truncated or deleted or like deleted some databases or Redshift clusters? It usually happens in startups. How many of you have done that? 2, 3? Okay. So I'll just tell a fun fact. When I joined as a fresher. I deleted one of our dev RDS, not production. So if you have that exposure, that's really good because you learn from your mistakes and you will never do that. And if you do that, it's okay, but you will never do that. Yeah. And data hygiene is one another thing. Why we use Redshift? What is Redshift? So Redshift is just a data warehouse. So we have RDS and we have Redshift. Why AWS implemented two things? So we will store all the junk data, everything, all the historical data to Redshift. We can delete data from RDS. No one cares, older data. If they don't want to get processed, we can delete those. But in Redshift, say like there is a requirement from CEO to get all the users who installed our application in 2016. It's easy to fetch data from Redshift than from RDS. That's why we use Redshift as data warehouse. So we'll have lot of chunk of data, like thousands of 10,000s of tables in Redshift. So basic thing is identify the tables or identify the data from respective stakeholders and try to clean up the data. Because we might have like lot of number of nodes in Redshift, but every Redshift node will also hold the storage. So let's say you have 3 nodes in Redshift and your total storage utilization is just 5%. It can be in TBs, but just 5%. Even though it's 5% of and the rest 95% is free, this 5% will be split across these 3 nodes. And it will take more time to load, to compute and do operations on your compute nodes. So that's how it becomes inefficient. So even if it's 5% storage or like 10% or 50%, whatever it be, clean the unwanted data and maintain the hygiene for all tables. Plus there will be lot of tables, unwanted tables present in your Redshift. So you can directly go ahead and delete consulting or getting a good go from your respective stakeholders. Then, yeah, query efficiency. This particular operation will enhance your queries, basically performance of your Redshift clusters. Less number of data, less number of operations you want to do. That's it, simple. Then optimizing space usage. We need to clean up, or we can do cleanups based on the historical data, how much we need or what we don't need. We can do that. And the other grade 3 operations that we did was to identify like top 500 CPU intensive consuming queries or time consuming queries. So you will have, as a data engineer, I don't know what all queries are coming to my Redshift cluster because I don't fire them. So data analytics team or like business analytics team, they keeps on firing queries for their requirement. So those can be optimized or won't be optimized. So 500 CPU intensive queries, if you can fetch them, optimize them and like put it in a good manner to a Redshift cluster, that is like the best optimization that you can do. Plus it applies the same for time consuming queries. So you can just fetch the 500 time consuming queries and optimize them. Give it to them, they can optimize because they wrote the query. They can optimize in a like more proper manner. You can do like some automations where you can fetch all these like say 10 or 20 queries every day, which consumes more CPU, more time, and send it to them. That would really help in your optimizing journey for the Redshift cluster. Then you can use the monitoring tool insights, like lot of monitoring tools is available in the market where you can optimize your Redshift cluster's performance. You can see the utilizations. Even CloudWatch provides a great metrics where you can see the utilizations. You can see the compute loads, etc. These are the query to get like the 500 CPU intensive queries in the last 7 days, unique queries. So I'm not going to explain all of this, but you can just keep in mind, and I'll try to create a GitHub repo where you can get all these queries or all the optimization queries that we have used to bring that cost to this cost. This is for like the last, for fetching the 500 most time consuming queries. And yeah, do you want me to explain these queries one by one? It won't be that good because even it feels very bored to see these queries now. And the other thing, the respective stakeholders like business analytics team or data analytics team, they will query, they will write queries to our Redshift cluster. And the cluster in Redshift cluster, how the Redshift query will be like, it will be like fetch 100 in SQL cur 100, 10,000 like that. Anyone saw that kind of sequence in your Redshift cluster? Where 1 equal to 1? Even I don't know, I got this query from like Google. But see, we just want to get the query, that's it. We don't want to deep dive into the query because if we get the data, then that's fine. So yeah, fetch in the queries fired from Tableau or other platforms, it will come to Redshift cluster like fetch 100 in SQL cursor like 10, 100, etc. We can't get the exact query from the AWS console or dashboard. So in order to get that, we ran these kind of queries where we will get the XID, the transaction ID, and the process ID of the respective queries, and we will add it in the second query, and we will finally get that like 100 lines of query or 200 lines of query. So that's how we got the queries fired from Tableau, and we gave it to like analytics team, and they can optimize that. That was one operation that we did. And there is other operation that we can do. One is to move the stale data to S3. We can just do an unload operation to S3 where we can push all the historical data to S3, clean up our Redshift cluster and keep the historical data in S3. And you can move even, like you can even save cost from S3 by moving it to other storage classes. So that is one way. And if you want the data, you can pull it from Redshift to S3, sorry, S3 to Redshift very easily. Like you can do copy operation on top of S3 to Redshift. So yeah, this is like a very small slide or like a very small presentation that I wanted to show on how we optimized our Redshift clusters. And thank you.